LibGDX support for tiled maps. As you know, a lot of video games are based on tiles. And the idea of tiles is that instead of drawing every game level from scratch, we create reasonably small number of reusable elements, patches of grass, patches of road, monsters, squares that our game pieces are made of, and so on. And then when we create our game levels, we build them in a special application, tiled, that you've already worked with, that allows you quickly build rather large level maps from these tile sets that you prepare in a graphics editor. And then you need software that can read these tile map layers and display them. Tiled outputs its level data in the tiled map XML TMX extension. And this is what a tiled map XML look like. So it's basically an XML file that begins with a section that describes map properties, such as whether it's orthogonal, hexagonal, and so on. Next, we have a description of the tile set. That's typically an image, tileset.png. And after this, we have a description of individual map layers. And there are three kinds of layers. There is image layer that basically specifies the background picture, and it has its width and height. Then we have tile layers, simple array of numbers, where each number specifies the number of the tile. So 0 means no tile, and 1, 2, 3 describes one of the tiles in the tile set. And then we have these object layers. Here in the XML, they're called object groups, and they specify different named object on the map and specify their parameters. By default, it has a coordinate, position on the map, in pixels, and width and height. So basically, objects are named rectangles, and we can use them to place monsters, player avatar, and things like that. I've shared with you a simple example called tiled map example, and I have it here ready to show. I have a separate folder called media where I keep source files for my graphics. So in this case, I have a background image, and I have tile set. So I have an empty tile, I have tile with an X and tile with an O. And I have a font that I'm going to use to print labels. So I've written a program that displays this tiled map. So in the source, in main resources, I've put the font and the necessary component for the tiled map, the background image, the tile set, and the map itself. For whatever reason, it's really tiny. Okay. So that's what it looks like. Why not? It has several layers. It has image layer, tile layer, and the object layer. And the object layer specifies single object, which is board, which is the square that's covering the board itself. So what I want to do is to display this board and display a message beside it that says something. So when I build it, I get an executable file, and when I run it, this is what I see. So let me now show you the code that displays this information. So first, remember that in our game, we have two classes at a minimum. One is the launcher and one is the game. So launcher in this case is not shown here. I will show it to you in the source editor. So if we go into main, we have in Java two classes, main and my game. So in the main, we create our application. And I set the window to be width and height of the game, and I make window non-resizable. Plus, I specify a window title. In the game itself, I define height and width as final static int parameters so that I can use them in the other class. And I define a bunch of fields. So I define field for the font, define field for the batch, sprite batch, and then I define tiled map. That's the object that holds the content of XML file. I define separate fields for different layers of the map. I don't have to do it. I don't really need to carry them always. I could define just the local variables, but I decided I'll put them here just for the educational purposes. So in my map, I have three layers. So I define three objects: image layer, tile layer, and just object layer. And I define separate field to hold objects individually. So those which we saw in the tiled. So for objects, I have an array to hold all of these guys, of which there is just one, which is board. Then I define several parameters that I want to get from the map for the purposes of positioning the map on my screen. I want to get map width, map height in pixels, and I want to get a rectangle that specifies not just the entire map, but the board in the map. Now, to draw the tiled map, I define an object for drawing orthogonal tiled maps, which is standard for LibGDX. It's called orthogonal tiled map renderer. And obviously, I need a camera to specify how I want to see the world plane on my screen. Next, I have create method in this game. And in create, I populate all of these fields. So I load the bitmap font. To load the tiled map, I use special object called tmx map loader, and it has method load, and you just give it a file name. By default, it looks for this file inside the jar file. If you want to load it externally, it has a special component called resolver, which you need to replace. And if you want, you can direct this map loader to look in the external file system or somewhere else. So now once I got the tiled map, I can extract individual layers from the map. So map itself has this method called getLayers, and what I get back is a collection of layers. And I can get individual layers using get method, where I refer to them either by name, which I specify in my tiled editor, object layer, tile layer, image layer, or I can refer to them by indices in the order of appearance, 0 being the furthest away from the viewer and second being the closest. So I get image layer, tile layer, object layer. Now from the object layer, I extract the objects, object layer dot get objects, and from image layer, I extract texture region from which I get region height and region width. Very often in software development practice, we have to deal with libraries that we have never ever seen before. And we have to learn how to use these libraries. And they can be quite obscure with no documentation or no software developers who know how to use it. So how do we do it? The answer is we experiment. and we use interactive debugging. So I just wanted to show you how I do it usually, so that you have some idea of how it can be done in other contexts. So I write a simple program which expresses my current understanding of what I'm to find. And if the library has debugging information, it can show me the content of variables, objects, and fields stored in these objects. And I can pause in the middle of my program, and I can simply examine what kind of fields I find and where in this data structure is what I need. So just for the purposes of example, I'm going to go into this my game, and I'm going to stop, put a breakpoint, say at the end of this method. So just after I finish initialization, I'm going to stop and I'm going to explore data structure in my interactive debugger. So in this kind of project, once you build your jar file, you can go libs, right click on it and choose debug. So important, you need to put a breakpoint, usually by clicking in this gray column, debug, stop and rerun. Okay, you saw it flash, window flash into existence. It doesn't show anything because I haven't got to the point where it starts drawing. I stopped it in the middle of create. And so it's gone through all of these lines, and now all of these variables have values assigned. Now, in your environment, in your debugger, you usually have a spot where you can look at the values of variables when it stops at a breakpoint. So in IDEA, it's down here called variables, and the one I'm looking for is this. This refers to the object in the method of which I have stopped. And underneath, I'll find all the fields of this object. And suppose I want to learn what do I get when I load a map. So I just navigate to this tiled map field, and I start exploring. So if I left click on it, I see the contents of the map. I get tile sets, I got owned resources, and I get layers. Okay, I'm interested in layers. So I click on layers. Here we have an array. I click on it. I see that it has 3 elements and some items. And when I click on items, I see them 0, 1, 2. And when I click on a particular item, I see the values. So I see that item number 0 is image layer, that it has texture region, that has name of the file, size, and layer number 2 is the tiled map layer with the name tile layer. And again, I see all those parameters. And number 2 is the object layer with objects and all the details about the objects that I can find there. So why do I need this? Often I cannot directly access all of these fields because they're private, but there are usually methods that allow me to access part or all of this data. So once I stop my program in its tracks and explore what I see in the debugger, what kind of data is there. After this, I can go back to the documentation and I can see which methods I have to get my hands onto this data. Now, very often you will find that what you see is not what you expect. And that kind of makes you think, maybe you misunderstood something, maybe it changes your understanding, your insight into what you see and how to work with this. And that's normal, that's typical. Now, when I get to use technology which I've never ever used before, notionally, I usually allocate myself 2 weeks in project plan just to get a handle of how to use it. So going back to this create method, by looking in the debugger on what I have inside these objects, I could understand what methods I need to call here to get my hands on the data items that I needed. So if you ask me, how did I know that I need to write all of this? Well, by looking in the debugger and then by looking in the description of the libgdx to see if I have method suitable for getting this kind of information. So, for example, I figured that I needed to get individual image layers through the method getLayers and through the method get. Then for the objects, I realized that I needed to get the objects array, this guy, and inside objects array, I needed to look at the items and get the appropriate item board by name. And that's what I'm doing here. So objects, get board, get properties. And properties, again, is part of the board object. And inside properties, we have properties array and key. It's a hash table. So keys, we have X, Y, height, and width, and the corresponding values as well. So then again, in turn, it allowed me to determine which properties to look for. And that brings us to the render method. Here I have several kind of sections. First, I clear the screen. Then I arrange my camera accordingly. Then I render the tiled map. And finally, I draw a message in the screen. Now, I wanted my display to look like this. So it's a relatively large window, and I wanted to have my tiled map in the middle of this window. And I wanted to have a hello message printed below it. Now, tiled map renderer always draws tiled map starting at the origin, at 0, 0. And if I want this map to be at a particular spot on my screen, I need to arrange my camera by kind of zooming out and shifting maybe, so that my tiled map is in the appropriate place. And all of the other elements I arrange accordingly. So in this instance, because map renderer always shows the map at 0, 0, I realized that by default, my camera looks at the region 0, 0 to heights and widths of the window. So I realized that I need to shift my camera a little bit down and a little bit to the left. So minus in the X direction and minus in the Y direction. And I want to shift it in such a way that my tiled map is right in the middle of the screen. So I have to do a calculation. So I get width of the window, which is 400. I subtract from it width of the map. That gives me the amount of white space. And I divide it by half, so that I have half of white space on the left, half of the white space on the right. And that's the amount by which I need to move my camera to the left and down. So that's this calculation here. Initially, I set camera to look at the window region from 0, 0 to 400 by 400. And then I translate, that's move camera down to the appropriate position. I do camera update to recalculate combined matrix, and then I specify parameters of the camera to renderer using its setView method. So that tells the renderer how to look at the map that it is to draw. And that's what it's doing. After this, I'm calling render method. It shows this map on the world plane and takes a snapshot of this map so that it looks right in the center of the window. And after this, I perform the batch draw. And again, I start batch draw with set projection matrix to camera combined. Again, it tells the batch how to look at the world plane after it has drawn whatever I ask it to draw. And then I draw hello smiley at the coordinates, world coordinates 0, 0. And see what I get. I get my hello, so 0, 0 coordinate is roughly here, just in the upper left corner of letter H. So up from 0, 0, we have tiled map, and below we have a text message. And because I kind of stepped back and to the side, all of this appears in the middle of my screen. So when you design your own game, you need to do something like this. You need to figure out in what coordinates to draw different things, where is the tiled map, how game pieces go into play, where the message is, and then you need to figure out how you arrange your camera so that when you kind of take a snapshot of what you have drawn, it's in the right position in the window. Okay, so thank you very much for your attention. I cannot delay you any further, and good luck with your assignment 4.